Hello Agilers! We're excited to bring you another powerful update from AgilePoint's AI and Machine Learning Toolkit, introducing the AI Control Tower. This cutting-edge feature is designed to revolutionize how you integrate predictive AI into your processes, all while maintaining governance control and a close collaboration between humans and AI. This journey actually began back in 2016, when we launched the first machine learning AI extender with the NX6. Then, on April 22, with the release of Software Update 2.4 for NX8, we introduced the AWS SageMaker integration. But those releases were just the foundation, laying the groundwork and setting up the stage for what would eventually become the AI Control Tower. With the AI Control Tower, you can seamlessly harness the power of predictive AI to streamline operation, reduce risks, and optimize decision-making, all without sacrificing oversight. So what exactly is the AI Control Tower? Well, it's a suite of monitoring activities that work in tandem with predictive AI, forming what we call Predictive AI Agent. This agent enables real-time monitoring, control, and adaptation of your process instances, dynamically adjusting them based on AI-driven predictions. Let's have a look. The AI Control Tower monitoring activities, also known as Predictive AI Agents, can be accessed via the Amazon SageMaker activity stencil. Here, you'll find 8 predictive AI agents, 4 designed with AI prediction models such as binary or multi-class classification and numeric prediction, and 4 are designed with machine learning vision such as image classification. Now, while these agents work in a similar manner, the key distinction lies in the specific action each predictive AI agent applies, depending on your process model needs and use case. Let's dive deeper. For this, let me switch to a process model where I have few predictive AI agents configured so we can review and learn their configuration. Now, here is the key difference. Unlike regular workflow activities, monitoring activities aren't part of the linear flow of the process. Instead, they float on top, subscribing to various process instance events, such as when activity starts, when activity completes, or encounter a particular condition. When these events occur, monitoring activity triggers a predefined action. This could be anything from sending a notification, initiating a sub-process, and more, enabling to enhance and adapt process behavior in real time. Let's now open the configuration of one of the predictive AI agents designed for predictive AI models so we can review and learn their configuration. I've opened the one for Adapt Flow, as can be seen on the title, which we'll understand what it means in a few minutes from now. Now, first thing we need to provide is a display name. Just simply name your predictive AI agent with some meaningful, straightforward name. Clicking on the next will head us to the actual predictive AI configuration. Now, the first thing we need to provide is the Amazon Access Token. As you probably know by now, Access Token can either be global, meaning it can be shared and reused by different applications, or it can be an application level Access Token, in which case it is private for the application in which it was created and can only be used by this application. Now, to quickly review the information required by Amazon Access Token, let's quickly head into the Manage Center where we can create Global Access Token. From Manage Center, we'll head into App Builder and then Global Access Token. As you can see, I already have 2 Amazon Global Access Token, but in order to show you the information and how you can create one from scratch, we'll head back into the Global Access Token page and click on a token. Now, from here we can scroll down and look for the access token type we are interested with, or better yet, just start type and it will filter down the list so we can more easily find the token type we're interested with. In our case, this would be the AWS access token. We can select it and click next, which will head us into the specific access token dialog window where we can provide the specific information required by this access token. Now, first thing we need to provide is the token name. Now, name is just a name, but make sure to provide a meaningful, straightforward name. Note that for global access token, the token name must be unique within your environment. Description is optional, but highly recommended for maintenance and management purpose. For long-term access key, you need to provide the access key ID and the secret key. Now those two you would get from your AWS account. Lastly, you need to select the region, and the region should be the one in which you have deployed your SageMaker endpoint to. Once you have provided all the required information, click on the test connection to make sure it can connect successfully, and then click on the save. Once you have your access token created, you can select it, and once selected, it will list down the different endpoint available within your SageMaker in that specific region. Now again, the region is the one provided with the access token. Now endpoint is the only mandatory field required. The other fields are optional. Now note that if you have provided an endpoint which is a multi-model endpoint, then target model field will be enabled. It is optional, but it will be enabled, and you can select the model inside this endpoint you would like to serve this the inference coming from this predictive AI agent. If model has not been selected, if you do not select the model, then it will either use the default model for that endpoint, or depending on routing rules you have configured for your endpoint or other configuration. Similarly, you can also provide a container host. If this endpoint includes more than one container, then you can provide a container host. And again, this would be specifically depending on how you configured your endpoint, SageMaker endpoint, but mostly the only thing you'll need is just the endpoint name itself. Once done with the endpoint and AWS configuration, then we can head into the triggering event. Now, as mentioned earlier, a monitoring activity, which is the core of the predictive AI agent, is unlike traditional process activities. It is not part of the linear flow of the process model, but instead it's floating on top of it and subscribe to a specific activity instance events. And when these events are being fired, then it will kick off the configuration of this specific predictive AI agent. And that's why it's called a monitoring activity. It's monitoring the event of this activity and subscribe to it. So under the activity, we will find the different activities, that is a process activities we have on this process model, and we can select any of them. And once selected, under the events, we will see the different events available for the selected activity, and we can select one of them. So we can, by this, we can subscribe to the enter activity instance of the wait for shipment activity event. And once this event will be fired in a specific process instance, then this configuration of the predictive AI agent will be kicked off and will follow with the request, response, and additional actions as configured, and we'll see later on. Okay. Now, on top of subscribing to a specific activity instance event, we can also add triggering condition. Now, this is completely optional, but you can add more condition on top of the event. So once the event will be fired, before moving on to the request, response, and additional actions, we will also evaluate the condition in here. And if it's evaluated to true, then we will follow with the rest. If it's evaluates to false, then we skip. We skip, we do not follow with the request, response, and additional actions, and we skip this event. Now, trigger condition is pretty similar to the conditional activity. You have an if statement, and inside the if statement you can configure a business rule expression. This can be either a simple business rule or a complex business rule. In our use case, for instance, we are checking that a product inside this order is one of very specific types, either a highly regulated product type, highly regulated for export, or a high demand product type, in which case we would like the help and prediction from an AI model. But again, this would be very specific to your process application needs and the business logic needs. Anyway, again, if this evaluates to true, then we consider this trigger, this condition to be true, and we will follow up with the request response and additional actions. And if this eventually evaluates to false and will exit from the else, then this condition will be evaluated as false, and we skip this event. We do not follow with the request response and additional actions. Once done with the triggering event, we can move on to configure the request. Now the request is the actual inference request, meaning what information, what input fields do we provide our AI prediction models with to provide us back with its prediction based on this input. Now this can either be a CSV type, comma separated list of values, or a JSON type. Now, unfortunately, at this point, SageMaker endpoints or models does not provide an auto discovery for the input schema required by the endpoint or model. So you need to know ahead of time what is the actual input schema required by your AI prediction model. And in the case of an CSV type, you need to provide the column list, and then you can just drag and drop the associated value from your available application data. But let's take it one step back and see the different options we have. Let's move to JSON and see the options, and then head to CSV. So in a JSON format, we have the option to provide and to read the payload from a specific variable. This means that we have a specific variable in application. Let's assume this would be this variable. And during runtime, this variable would have the complete JSON payload of the schema and values required by the AI prediction model. So this JSON would be something like this. Okay, so we have the schema and we have the values for each of the properties, and again this complete JSON would be the value of this variable during runtime, and we can provide this as an input for the AI prediction model to provide us with its prediction. Another option is just to map from our schema, from our application data. So in that case, we need to provide the expected JSON payload by the AI prediction model. So this again would be something like this. The payload would look something like this. Sorry, copy again and paste. Okay, and once we have the payload provided, we can just map from our schema, and this would be the schema mapper, as you probably already know from your Agile Point, as it's very similar to many other areas in the product. So like shipping method to shipping method, and shipping address to country, and so on and so forth. Just map the fields accordingly. And lastly, we have the map to grid, which we can see in the CSV type. So in the CSV type, we go in here, and again we have the same option, read payload from this variable. So assuming this would be let's say this variable. Okay, this variable during runtime should have a comma separated list of values expected by our AI prediction model. So this would be something like this. Okay, a comma separated list of values. Or we can map to grid. In this case, we need to provide the column names as a grid and associated them with the specific values from application. So this would be something like this. The first field is the shipment method, so, and the value is in my data source. Can search for it, method, so shipment method. And I'm gonna add another column. This would be shipment duration, and now this should be in my form fields, days, Okay, and another one, this would be the from country. So from country, I'm gonna provide a hard-coded values because we currently only have one logistic warehouse which is in the US, and to country I think is the next one, but let's have a look. Yeah, shipping country. So this would be country, ship to country. This would be this field. And lastly, I think it's the return reason. Yeah, so let's add another one, return reason, and this would be return reason, and that's it. Okay, so this is how you map a CSV or a grid. Now one thing to note about CSV type is that, and it's noted in here, the order is order sensitive, meaning you must provide the same order of the fields as expected by your AI prediction model input. And this order would be the same order as the model was introduced with during its training. So you need to know what is the expected columns and what are their orders, and make sure to provide the right columns order in for the input. And that's basically it. That's the request. Once done with the request, we can move on and configure the response. And the response is the actual prediction information we get back from the AI prediction model based on the input we provided him over the request. And this part should look and feel quite familiar to you, as it's being used in a very similar manner across many different activities and lookups, and generally across the AgilePoint platform. So we can either map the response to the application schema or store the response in a variable. And if we go with the first option, which is the most common one, we click on this schema icon, and it will open up the schema mapper dialog. And on the left hand side, we will have the AI prediction model schema response, which has a label, a probability, and a score. Actually, the score in most cases of SageMaker will be empty, and we can just drag and connect them to the corresponding field in our application schema, which will show on the right hand side. So in this case, as you can see, label is being mapped into this data source shipping risk label, prediction shipping risk label, and the probability is mapped into the predicted shipping risk probability on our data source. And that's pretty much it. And again, this should look and feel quite familiar to you, as in being used in a very similar manner across the AgilePoint platform, and you've probably already used this many times while using AgilePoint. Once done with the response, we can move on and configure the additional actions. Now, the additional action is the main differentiator between the different predictive AI agents, and this would determine the specific actions you can take according to the prediction provided by the AI prediction model to dynamically adapt your process instance in real time. As mentioned, this specific predictive AI agent is of type adapt flow action type, as we can see in its title, which means it allows us to skip or roll back the model from the current activity it is in into another activity. Actions are being set from the set action trigger condition, and in here we can provide a condition in which, when evaluates to true, we will take this specific action. Now again, this is a predictive AI agent of type adapt flow action, which means the action will always be type of change flow. So we can provide an activity to change to either by opening this drop down, and this drop down will list all the different process activities in this process model, and we can select any of them. And when evaluates to true, we will change the flow into this activity, meaning the process will be moved from the current active activity to the provided activity in here. So this is one option. Another option is just to use a process variable or an activity, an application variable available to us, and drag it in here. And this variable should include in runtime a valid name of an activity we have in this process, which means that basically we can use an AI model to predict the next activity and use its prediction provided to change the process too. And I'll show you this use case later on. Now, if we click on this edit icon to see the condition inside, we will open up the condition builder, which is quite similar to what we've already seen in the triggering event condition, and it's quite similar to the actual traditional condition activity. And it can either be a simple expression or a complex expression. In here, we currently have kind of a complex expression with 3 parts. First, we check we got some prediction data. Then we check if the label is not equal to low. And just to give you some kind of a background about the AI prediction model we are using in here, it's an AI prediction model that is trained to predict the risk of shipping to be delayed. It's a multi-class prediction model which will provide one of 3 classes, either high for high risk, moderate for moderate risk, and low for low risk. So basically we are checking in here if the label, the class, is not equal to low, meaning it's either a high risk or a moderate risk, and the probability is greater or equal to 0.9, which means 90%. So if we got prediction data and the prediction is either high or moderate risk, meaning not low, and the probability is greater or equal to 90%, then we want to take this action and change the flow to the shipping details activity. Okay. Likewise, we can add as many rules as we need, and for each of the rules set their needed conditions and take the corresponding actions accordingly. And lastly, we can use the else as do nothing. So if none of the rules condition has been met and evaluated true and we took no actions, then the else would be do nothing, and we don't provide any change flow configuration, as you can see in here. And that's basically the adapt flow activity. Aside from the set action trigger condition, which will include a specific action per predictive AI agent action type, we can also find in the additional action the status and error messages, which you may already be familiar with from automatic activities properties. So this includes 2 optional attributes, the status and the error message, which the status will include true if the execution of the predictive AI agent has been successful, and it will include a value of false if during the execution of the predictive AI agent something got wrong, some exception or an error has been raised. And in the case of an exception or an error has been raised, then the error message attribute will include the actual error message that has been raised. Now again, keep in mind those 2 are optional but highly recommended to be used because they are quite efficient and useful during runtime to troubleshoot if anything goes wrong. Additionally, you have the option to enable suspend process instance if exception has occurred. So as the name suggests, during the execution of the prediction AI model, if some kind of an error or exception raised, if this is enabled, then the complete process instance will be suspended. So it gives the admin some chance to go and check and fix whatever happens there, whatever issue has been raised, before it resumes, so the prediction can be successful. And similarly, if we enable debug, then the Agile Point log will include more trace information about the execution of the predictive AI agent. We have now completed the full review of the configuration, options, and anatomy of a predictive AI agent. This was specifically for the adapt flow action type, but it would be identical and same for all other predictive AI agents. The only difference would be in the action triggering condition, where it's going to have the specific action according to the action type of the predictive AI agent. Meaning, change flow or send notification or initiate sub-process and accordingly. But other than that, all other configuration would be identical. That has been said, make sure to, once you completed all the configuration, click on the save, or make sure to click on the save as you are moving across the different configuration to keep your current configuration. Now, note also that you can create multiple configuration. So basically, each predictive AI agent can have more than one configuration, and actually as many as needed. And each configuration can be configured completely independently and different, or can overlap with some of the other configurations. So it can have a different, say, connect to a different SageMaker environment, or to the same, connect to configure a different triggering event, or apply the same triggering event and just connect with a different predictive AI model. Obviously, configure the request according to your endpoint. Response would typically be looking very similar, and eventually have a different trigger conditions. Keep in mind that the action would always be similar because it's based on the action type of the predictive AI agent, but you can apply different rules, different and different actions according to this rule as you need. So you can add more than one configuration per predictive AI agent. That has been said, I'm going to remove this and let's skip just this one, predict shipping, and let's now move and have a look on another action type of a predictive AI agent. I'm going to open up the configuration of this predictive AI agent. This one is of type initiate sub-process, and like any other activity, it starts with a display name, and if I click the next and we'll get to the actual predictive AI configuration, we can immediately see that it has the same exact anatomy and configuration option as the adapt flow predictive AI agent that we've seen previously. So this one also currently have just one configuration, but we can add as many as we need. It has the same configuration options for the Amazon Web Services, same configuration options for the trigger event, same for the request, same for the response, and lastly, same for the additional actions, with one exception lies in the additional action. This one is of type initiate sub-process. So the action we can take is to initiate a sub-process, where we have the option to configure which sub-process we would like to initiate, and under this drop-down we will have all available processes in this environment to be used as a sub-process. We can select any of them, and we can also click on this configuration to decide how we are going to share or not data with this sub-process. And this has the same configuration and concept as you're probably familiar with from the sub-process activity. And lastly, we can decide whether to apply this action for all sessions or just for the first session. Now, if you are not familiar with what session is, in a nutshell, a session is like a counter for each time an activity executes in a given process instance. Okay, or put it another way, it's a counter for how many times a process went through a specific activity and executed it. So to remind you, we are subscribing to this activity event. So for first session only means only the first time the process goes through the activity we are subscribing to and the event has been raised. And for our all subsequent sessions, we will just skip and ignore taking the action. And for all sessions mean anytime process goes through this activity and raise the event, we will take the action. But that's it. Basically, it has, as you have seen, it has the same exact anatomy and configuration with one exception on the action type, because this one is of type initiate sub-process. That has been said, let's now open another predictive AI agent. This one is of type get prediction. So like the name implies, this one just get a prediction. It doesn't have its own action. It doesn't take any action by its own. Just go run the inference, get a prediction, and that's it. The action can be taken by either one of the process activities or maybe even by another predictive AI agent. So as you can see immediately, it has again the same configuration and anatomy. This one again also have just one configuration, but we can add as many as we need. Same configuration options for the Amazon Web Services, same for the triggering event, same for the request, for the response, and same for the additional actions, with the one exception lays in here in the additional action. Again, this one just get a prediction, doesn't have its own action, so we don't have any action to configure in here, and that's pretty much it. And if I'll drag and drop and put another one let's go in here and use the send notification predictive AI agent. So again, we will immediately see it has the same configuration options and anatomy. So let me add a configuration, and again, same configuration for the Amazon Web Services, same configuration options for the triggering event, for the request, for the response, and for the additional actions, with one exception in the action we can take. This one is of type send notification, so we can decide which notification to be sent, and this will show all the email template that we have in this process model. We can use any of them to be for the notification to be sent. And again, same idea with either only apply this action for the first session or for all sessions. So again, they all work with the same pattern, same options, same anatomy. The only difference is the action they will take. That has been said, let's now let me remove this, and let's now run this process in runtime from the work center, so we can see how this predictive AI agent behave during runtime and how they can impact and change and adapt our process instance in real time.